Okay, in this video we just want to go over all the different graph shapes of what you're going to linearize and what you'll end up doing to your data to make it a linearized data. I know these are table of values because we're linearized. This is Mathland, so these are really values, not data, but we're going to be dealing with data. So we've already talked about this one in the last video, but just to review is if you plot from your original data, if you plot a graph like this, I know this is math y and math x, but that screams out that y is proportional to x squared. Then you need to create your linear data. But let's go ahead and here, because why are you going to create this anyway? Because ultimately you want to plot it. So if you see this graph shape, you're going to plot y versus x squared. So basically, whatever this is goes on this axis. So this is why you're going to create your linearized data table with the x squared. But what if you see, ooh, you're seeing down here, what if you see a graph shape like this? Well, this suggests strongly that y is proportional to 1 over x, or y is inversely proportional to x. So let's talk about that one. So this is your original, again, these are table of values, they're made up, they're not even values, right? But this is going to become this would be your data. Okay, what do you need to do? Well, this gets weird. You don't do the x squared here, you do 1 over x. Now, why am I doing 1 over x? This was x squared. Well, because this matches this, and so whatever this is, y is proportional to 1 over x, then you need to do that to your original data. So in this case, we're going to take our table of values. Well, we're going to do nothing to the y, right? We do nothing to the y, but the x, instead of having x, we're going to have 1 over x. So whatever you do, I mean, you just basically do the 1 over to whatever value you have in your input variable. So 0, wait, you can't have 1 over 0. That's eep. So this would actually be not, you're not going to have a data plot. I'm going to pause because my brain's hurting. Okay, I figured it out. You're never going to have that as a data point because you can't collect data there, because in this example, when x is 0, y is infinity. So forget that. That one doesn't belong. That's why. All right. So suppose that your x is 1. Well, 1 over 1 is 1. Then you say, okay, well, when my x is 2, what is 1 over 2? That becomes 0.5. When it's 3, 1 over 3 is 0.33. I'm not worried about sig figs here. When x is 4, 1 over 4 is 0.25. Okay, then here's the thing. What are you going to do? You're going to plot your original y versus not x, but 1 over x. And you're going to get a straight line. I forgot to do that. You're also going to get a straight line here, but I'm talking about this graph here now. So basically, the equation for this is going to be y equals, let's suppose your slope was, I'm making it up now, but just have a slope value. I guess I'll just call it m, right? It's going to be m, but it's not y equals m times x. It's y equals m times whatever this axis is. So it's going to be 1 over x. So that would be the equation for this guy. Let's go back and do this one. If you get a slope of m on your linearized graph, then the equation is going to be y equals m times x squared. All right, the last graph shape is the sideways parabola, which suggests that y is proportional to the square root of x. So similar process. Ultimately, you're going to be graphing, since this is y is proportional to the square root of x, your linearized graph, you're going to plot y versus not x, but the square root of x. So then you need to take your original data table and you're going to linearize it by making a second data table. Your y's don't change, but now you've got to take the square root of your x value. So whatever your input, again, so in our case, this is going to be real data. So this is going to be our input. This is going to be our linearized input. And so the idea is take whatever your original input variable is, the quantity, and take the square root of it. So the square root of 0 is 0. The square root of 1 is 1. The square root of 2, okay, you're going to need to put that in your calculator. I just got a little lazy. It's like 1 point something. Well, I know it's 1 point something. Okay, square root of 3 is, again, you're going to put that in your calculator. Square root of 4, okay, I got really lazy because I know that's 2. All right, and then you're going to plot that. And when you do, you'll get some kind of a straight line. And so how do you get the equation for the original graph? Again, your goal is to get the equation for this all these original graph shapes. Well, on your linearized graph, you're going to find the slope. And let's just, once again, we're calling it m. And so now your equation is going to be y equals m, the slope, not times x. One more time, not times x. It's whatever this is, the square root of x. So this is the equation. This is called linearizing the data. That's kind of just an informal name for it. I don't think that's the formal name. This is something that the AP physics people want you to be familiar with. We're going to do this about 3 or 4 times during the course of the year. And I could see, so on the AP exam, I could see them saying, you know, just as part of an overall question, they might say, what would you plot in order to develop an equation for this relationship? So you're not going to be doing a lot of actual graphing on the AP exam. I'm getting a little bit distracted, but I mean, but you need to understand the process. But in our labs, at least twice this year, and if we have time, 3 times this year, you're going to go through this process with real data to come up with equations for non-linear data.